So you wanted to do C3
Or B2. Yeah, you can do C3.
and C4. Okay, so C3. C3 was different because there were 3 chunks. And it was an explosion instead of something hitting something. And people freaked out and said, it must be different. And it's not. You still have your little grenade. And so your grenade is flying through the air initially with how much momentum? So we say it had 1.57 kilogram mass, and it was traveling at 4.28 meters per second. So how much momentum did it have? We would just multiply those out. And we end up with 6.720 Newton seconds of momentum. So that's how much we had before it exploded. So how much are we going to have after it explodes? It's the exact same number because the before and the after are the same. Before and after an explosion, before and after a collision, before and after any interaction with other objects. So, yeah. So now it breaks into chunks. So our first chunk, after it exploded, chunk 1 went 27 degrees to the right. So compared to the original motion, it went 27 degrees this way. And it said that chunk 1 was 0.578. And it was traveling at 55.7. Now you may be saying to yourself, it's going a lot faster than the original was going. And I would say, yes. So now all of a sudden we have 32.19 Newton seconds of momentum. Whereas before we only had 6 Newton seconds. And you're saying, wow, we got all kinds of extra momentum. No, we don't. We still have the same total momentum. But each chunk has more momentum. But that's okay because there was an explosion. And that added some increase to everything. So then we have a second chunk. And the second chunk flew 42 degrees to the left. So it's going to go 42 degrees this way. And it had a mass of 0.357. And it was traveling at 78.2. So when we multiply that out, we find that had 27.92 Newton seconds of momentum. So now we want to find out what is chunk 3's mass, what is its velocity, and what is its angle. Well, the first part is super duper easy. How do we find the missing mass?
Subtract your extra.
Yeah, we say, well, this is the total mass, and I have this chunk of mass, and I have that chunk of mass, so all I would have to do is subtract those. So 1.57 minus 0.357 minus 0.578 gives me 0.635 kilograms. So that was really tough, right? We had mass to begin with, we still have mass at the end, because mass is always conserved also, unless it turns into energy. But that didn't happen here, other than a little of it, when it went boom. Okay, so next we gotta find a velocity. How do we find velocity? We find velocity from conservation of momentum. So the first chunk was going to the right, which means it was going both forward and over to the side. The second chunk was going to the left, which means it was going forward and over to the side. So how do I find out what these are? So again, the adjacent sides we're going to use cosine, and the opposite sides we're going to use sine. So if I take the cosine of 27 times 32.19. That gives me 28.68. And if I do sine, I'm going to get 14.61. And if I do cosine of 42 times 27.92, I get 20.75. And for sine, we get 18.6. Everybody with me so far?
Yes.
Okay, so how much momentum did we have before the explosion?
1.57.
We had 6.72 going straight forward. How much do we have going straight forward now? Straight forward now would be the 20.75 plus the 28.68.
40.
So we have a total of 49.43 Newton seconds going forward. So you're saying to yourself, wait a minute, we only had 6 before and now we have 49. No, we still have 6. How do we still have 6? We have a third chunk. Clearly, what direction does the third chunk have to be flying? The other direction. So we say, hey, we must be, what adds up to 49.43 to give me 6.72? We get 6.72 minus the 49.43. So we are missing negative 42.71 Newton seconds of momentum over here. And again, negative momentum just means it's flying the opposite direction. So the third chunk must be flying this way, and it must have a sideways or a forward to backwards momentum, clearly backwards in this case, of that much. Does that make sense? That way these two numbers add up to what that number was before. These two add up to that. Okay, we know that the forward is equal to the forward, but we also have to know the side has to equal to the side. And initially the grenade was thrown forward, it wasn't thrown to the sides at all. So the total to the side should cancel out. Does it cancel out?
No.
Right now it doesn't cancel out. And we say, hey, I've got 18 going this way and I've only got 14 going this way, so I'm missing some going to the right. How much am I missing going to the right? We just take 18.68 minus 14.61. And that means we're missing 4.07 Newton seconds going to the right. So that means my third chunk must have 4.07 going that way. Copy? So the total forward is still equal to what it was beforehand, and the total to the sides are canceling each other out. So now that I know this is how much my third chunk has to have, then I can figure out what that resultant is by just Pythagorizing. So plus 42.71. And theirs turns out to 42.90 Newton seconds. So if I want to know the velocity, I know that P divided by M equals velocity. So I need to divide by the mass that we already figured out chunk 3 had. And we get 67.6 meters per second. That's how fast that chunk should be flying. and now we gotta figure out what angle it's flying at. So, if I'm looking for that angle, again, I always want to use tangent to the -1, and tangent is always opposite over adjacent, so we're gonna have 4.07 over 42.7, and that's gonna be 5 degrees. Now, that doesn't mean it's going 5 degrees, because again, we were counting these angles compared to the direction of the original motion. So one went 42 to the left, one went 27 to the right. This one, compared to the original motion, would be going, the original motion was this way. If this is 5 degrees, then that means we have gone 175 degrees to the right. That make sense? So the angle is 175 degrees. And really the only equation we used was P equals MV. Over and over and over.